In this video, I'm going to present you the SketchMiner, a tool we have developed for sketching process models by mining participant stories, written down in a DSL, that is a domain-specific language that we have designed for the purpose. To demonstrate the DSL and the tool, I will use a simplified example of a travel costs reimbursement process, which can have two possible outcomes: the approval or the rejection of the request. Now, there are different participants in this process, such as the employee, the head of department, and finance. And the DSL uses participant as a keyword followed by the name of the participant. So imagine that I am the employee. So I state that I'm the employee, and then I can basically create the list of tasks that I perform as part of this process. So I can tell my story of how do I participate in the process. So let's say I fill in the form, I mark the bills, and then I send the dossier. Now, I don't exactly know what happens after I send the dossier, what type of controls are there in place, etc. So I state this lack of knowledge of mine by using the three dots symbol. And then the head of the department knows that he does not start the process, so the process arrives to him from somebody. So it's being handed over to him by somebody, which is the employee. So he states the last activity of the person who hands him in the process, which is sent the dossier. And then the head of department can state all of the controls that he does. So check the costs, check the description, and then he can decide to, let's say, reject the request. So, as you can notice, the tool basically transforms the provided task lists by the employee and the head of department into a log, connecting them different fragments into a full process instance trace based on a common activity, in this case, sent the dossier. Then it feeds the log to a mining algorithm, which reconstructs the control flow, which is then rendered by the tool at real time. Of course, if the mining log is just being fed one trace, the discovered process is sequential. However, the head of department can also decide to approve the request. Now, instead of stating all of the activities that he performs all over again, he can basically just state the last activity that he performs before making a decision, and then state how the process instance differs when the request is actually being approved. So approve the request, and he states that then he sends it to finance. And he states that this is just a process fragment, so the process does not end here. But he is not knowledgeable about what happens after. So this is where the participant finance steps in. And he states that he does not start the process, but once he is being sent the dossier, he will check reimbursability of the process, and then send the payment to the employee. Send payment. So as you can see, the tool has actually expanded all of these different process fragments into two traces. A trace where the request is being rejected, and a trace where the request is being approved and is being paid by the finance department. The tool can also discover loops. So let's say that the head of department actually would, after performing all of the needed checks, so just stating the last activity that he performs before making a decision, he can decide to ask for modification. Then the participant employee, when he is being asked for modification, he, let's say, does the modification and then send the dossier again back to the head of department. So as you can see, the tool has also discovered this last possible process instance where a loop can be taken. So where the employee is being asked to do the modifications and then his request is being rejected. But also it can happen that he is being asked to do the modifications and then his request gets approved. So the tool expands all of the possible process instances. That is, he discovers all. It expands all of the fragments in order to derive all of the traces that can be supported by this process, and then uses the mining algorithm in order to discover the process. Now, as the targeted users of this tool are the process participants who not always have modeling language knowledge, we do not require them to use any modeling language terminology, such as gateways, for example, or loops, start events, end events, etc. Also, we do not ask them to be aware of any programming language terminology, such as if-else, which is very common in other textual languages used for building visual models, such as PlantUML. So if you're curious about this project and about this tool, please do not hesitate to contact us, and we will be happy to provide more details.